Basically, what is IPS profile? So IPS is an intrusion prevention system, which is available on Fortinet Firewall. And the way IPS work is by matching signatures to any known exploits or vulnerabilities. So Firewall has this list of all the exploits and vulnerabilities that is available. Uh, and this list gets periodically gets updated by the through the FortiGuard update service. So firewall will match these signatures with the pass-through traffic on the firewall, and if any known exploit is seen, the default action will be applied, or as administrators we can set our own custom action. So based on that, the action will be taken. So there are two ways to apply this signatures. One is by taking action based on the default action which we get through FortiGuard, and the another is through by taking a rate-based action. So when we say rate-based action, uh, it's in a way that firewall will detect anomalies or unusual network behaviors on a traffic. So, for example, let's say if we enable rate-based signature, and let's say we have a RDP server in our network. If someone is trying to brute force into the RDP server, then firewall will detect that brute force attack and will limit the connection. Now, after a threshold, certain period or a threshold is value is reached, now firewall will start blocking all the connection from it can be from a particular source or to a particular destination. All the connections will be blocked because a certain rate of connection has been reached for that particular device, and a firewall has detected a network anomaly there. So that is one way. And the another is by detecting the signatures. So all of these IPS signatures have their own unique pattern, and firewall will scan through this traffic, and most of the signatures can be applied even if the traffic is encrypted, but some signatures needs the connection to be decrypted. So firewall can scan through the traffic, and if it sees a pattern, a known pattern, then it will start blocking those connections. So if you have noticed, in antivirus mode or in web filter, we have to create them in flow-based and policy-based modes. But for intrusion prevention, we don't have to create them in either proxy or flow. So it can work in both proxy and flow. Whichever profile we create, it can work in both proxy and flow. So in IPS, we have something called protocol decoders. The protocol decoders were also available in antivirus and web filter, where they will allow the connection even if the for a well-known protocol the port number is changed. But in IPS, if they detect a change in protocol flow, then and the firewall will try to parse the protocol. If it couldn't parse the protocol well enough, then it will create a protocol error. So and that connection will be blocked. So if you remember yesterday, I showed you the difference between different type of engines available in the firewall. So one of them is IPS engine and another is WAD. So this IPS helper and IPS engine, so they are responsible for flow-based antivirus protection, then web filtering, application control, and email filtering. So along with the IPS signatures, because this IPS name comes again and again in the firewall in FortiGate in multiple places, but don't get confused. This IPS engine or IPS helper, they not only do the IPS based inspection, but they also handle the application control, then the flow based antivirus signature antivirus protection, then the web filtering and email filtering. So these functions are all done by IPS engine. So all the other functions like proxy-based antivirus or your proxy-based web filtering or anything related to proxy, they will be handled by the WAD application. Now, the signature along with this signatures, default signatures available on the firewall, we can also create our own custom signatures, but there is a procedure to it. So if we know the pattern, then we can create these signatures, and the same can be applied in our policy. So before applying the signatures in the policy, we have to create a profile. So these are the default profiles available in the firewall. So let's see. So by default, there is no specific signature being matched or specific signature being used. This varies with okay, this varies with profiles, but if we consider this Wi-Fi default profile, it has a set of IPS signatures being selected. So basically, they anything with these severities, they have selected and they have applied on the Wi-Fi default profile. But we can either use the default profiles or we can create our own profile. So IPS profile, IPS signature matching basically works just by looking into the pattern of the data and see if there is any malicious pattern being detected. So the first thing, first place where we can check for any of this malicious or a known pattern is by checking the URL. So if the URL is known to be malicious or if the domain is malicious, then we can block it straight away without looking into the content. So that option is available here, block malicious URL. And then we get the option to choose IPS signatures and filters. So here we can either go with filters, and when we say filters, these are the filters: the name, severity, target, OS, action, and then we can go with specific signature. When we go with specific signature, we have to manually select these signatures. So whichever signature we select, they will be added to the they'll be added to the profile. So once we click on these signatures, then we can do add selected and it will be added. So let's discuss the filters first. So in filters, we get to choose the action. So the first one is the default. So when we say default, each signature comes with its own action. So for example, this FTP information disclosure, this is a severity 2 vulnerability. So for this reason, the default action is set to pass. Now, if you consider let's say this FTP server buffer overflow, this is a severity 4 vulnerability, and this action is set to block. So if you leave this action to default here, this action will be taken. On the other hand, if you set your action to monitor, then your action, then for all the signatures which you apply, your action will be monitored. So whenever a firewall will allow the connection, but at the same time it will generate a log for you for initial days, or for if we are not sure like how to what signature to allow and block, then monitor could be a good action. Then if we set to block, all signatures will be blocked, and then if we set to reset, there'll be what reset, and then quarantine is an important function. So when we set to quarantine, we get an option to choose a time period. So if firewall detects a vulnerability and if the action is set to quarantine, then all the whatever machine that initiated the traffic, that will be quarantined for a certain time period which we select. Then comes the packet logging. So if we enable packet logging and if there's a malicious traffic going through, and if it's happening, um, well, if it's detected as a malicious traffic, the packet capture will be taken by the firewall and will be kept. So this packet capture can be later analyzed by the SOC team to uh, generate custom signatures if needed. then the status to enable, disable, or default, and then here comes the filters. So in filters, you can select whether want to protect your client machine and you want to protect them from severity 5 vulnerabilities, and they are using DNS protocol. So you should not blindly choose all the signatures, because by default, Firewall has over like 5,000 signatures. Now, if you apply all this 5,000 signatures to your firewall policy, for each and every traffic that is going through the firewall policy, firewall has to scan them. So that is CPU intensive and memory intensive as well. So your device can go to conserve mode. So to avoid this scenario, we need to know like what protocol is allowed in that particular policy and what service and whether we have to protect the client or the server. So based on the requirement, we need to select the signatures. By doing so, we can limit the number of signatures available for scanning. So in with that, the packet processing can be done faster by the firewall. So even if we, for example, for DNS protocol, let's say we have a DNS server and we selected all the severity 2, 3, 1, 2, 3, 4, 5, all severity signatures, we end up with 34 signatures. Now, if we know for a fact that we have a DNS server that has to be protected, and if it's a server, and then in that case, if I go with this method, like where I selected all severities and the DNS protocol, then I end up with 34 signatures. Now for the 34 signatures, the firewall can easily process them. To say the firewall can process these signatures in a much faster and efficient way. But if we end up selecting all 5,000 signatures, then the firewall will get high CPU or high memory issues. Now I can also go with signature, and let's say I want to do rate-based setting. So in rate-based, I don't want to go with default. I want to specify. And let's say the threshold, let's say if I get more than 5 connections per second and then block them for a period of 60 seconds. Now let's say DNS. One moment. Let's go with RDP. Nagarajan, I didn't get your question. Can you please elaborate on this? So let's select RDP brute force. If I select the signature and then if the threshold is set to 5 and the duration for 60 seconds, and it can be from a specific destination IP, let's say we have a machine which is edit. Let's say this is one of our jump server in our network, and it can be accessed by anyone, and we wanted to protect this jump server from attacks. So if someone is trying to brute force into the jump server, then we can set this particular threshold, and then we can apply this signature. Okay, add selected. So we have to select the signature. Let me select the RDP one. RDP brute force, add selected. So this one signature has been selected, and now this is using rate limit. The first set of signatures are doing scanning based on the traffic pattern, and the second signature is doing a rate-based protection. Let me check this. Nagaraj, can you please explain? I didn't get what you're asking. DNS block not resolved. Website is it correct? Filter, we selected DNS. Nagaraj, are you asking about an issue which you're facing in lab? Oh, in your office. Nagaraj, we will discuss this later. Now we are focusing on the class. We will discuss it later. Okay. Okay, now we might get an question, a curious question. Where to apply IPS and what's the purpose of IPS? So the purpose of IPS is to protect our inside network from outside threats. So we don't have to apply the IPS profile or IPS scanning for any traffic that is leaving our network. But we should apply IPS for all the traffic that is incoming to the network. Now, if you have a if you have a server that is behind your network, it is very logical to apply IPS for to protect those servers. But anyone from the network can initiate a connection to any service in the internet, and they are also going to respond back. So you might get a question. So do we need to apply an IPS profile on those policies where the return traffic from the internet will come in? So in those scenarios, we can do IPS, but that is not ideal. But instead of that, what we can do antivirus and web filtering, where we can restrict the users from accessing certain malicious domains so that they won't end up in a malicious domain. And also we can do antivirus based filtering that which will scan all the incoming traffic for any attachments which may be malicious. So we need to understand this distinction on where to use what profile, and if we do it accordingly, we can save the firewall resources, and we will get a good performance out of the FortiGate firewall. Now, along with this, the IPS signatures, we also get this botnet command and control. So if any of your connections, let's say if you choose to apply this IPS profile on a policy which also handles outgoing connection, you can enable this feature which scans your network, which scans the traffic for to see if the connections are going towards any known command and control domains or destinations. So we can either monitor it or we can block it. Now in monitor, we have this range of IP addresses and their port numbers. So these are some of the known destinations which are being used for command and control. So command and control is a method being used by hackers to take control of your machines or to exploit any vulnerability available in the system. So if we know, like if we see any of the connections going towards this destination, then we can, if we choose to monitor, we will get a log generated which says this particular PC is trying to connect with the command and control destination, or we can block them right away. So now we have this profile, and now there is another question on what order this IPS will be inspected. So currently we have two profiles, two signatures are selected in this. So the blocking, the order of matching will happen from the top to bottom. So we need to always keep the specific signatures on the top, and then the broader signatures at the bottom. So Ramya has a question: shouldn't we block the botnet sites? Why do we need to monitor them? So Ramya, the monitor option is something that is available for administrators, so that you will get a log being generated saying that this machine is trying to reach this particular botnet site. It's not that if you set the action to monitor, your end clients will be allowed to reach to the botnet site. The connection won't be successful. Your other IPS signatures or your antivirus filtering, they will come in and they will block the connection. But you will get a log being generated. Now, in this, how do we control the logging exactly? So the logging for this particular profile will be controlled from the policy. So whatever logging we enable in the policy, so the same will be applied. So if we enable for security events, then only the UTM logs will be generated. But if we enable all session, both security and UTM logs will be generated. So that is the very short intro for IPS. So we can select whatever signature we want to apply and then to the policy to save them. Now let's discuss about another important UTM profile, that is the application control. So this application signature matching is also performed by IPS Engine. Now, IPS Engine is different from the IPS signatures. These are two different things. So, IPS Engine is the process or application that is running in the firewall that helps again in matching the application to the traffic pattern which we are receiving. So, again, similar to IPS profile, it can work in both proxy mode and flow mode. Not a problem. But there are certain applications which need decryption to be enabled. I mean, deep inspection. If deep inspection is not enabled, those application won't be detected. So how do we know if we need deep inspection to be enabled for those application? So if we hover over these applications, we will get a padlock symbol, which indicates that we need deep inspection to be enabled for that application to work. Please give me a minute, guys. Okay, I'm back. So if you hover over these applications, we will also get to know what protocol they are going to use to connect. So if those protocols are not being inspected, then in those scenarios as well, the application signature will not match. For example, this particular backup execute, this is using TCP and NBSS protocol. So if NBSS protocol is not being inspected or allowed in the service, then in the policy, then this application will not work. So if we are doing application detection on a policy that goes through flow, allows this traffic, these services must also be enabled. We should easily see something that needs decryption. Why couldn't find some? Basically, we will see a padlock symbol that says we need decryption to be enabled. Okay. So there is a unique scenario in application-based signature matching. So, for example, application signature will work by detecting a unique pattern in every application. So, but nowadays, lot of applications uses protocols which are well defined and which are being commonly used by a lot of other services. So in those situations, it is possible that an application might get identified as something else. For example, HTTPS. So HTTPS browser or RDP over HTTPS. So this HTTPS browser, they work based on the TCP and SSL as their main protocol. Now, the same protocol will be used by some well-known applications like Facebook. So if you check, they also use HTTP, TCP, SSL. So it is possible that sometimes your Facebook traffic will get identified as HTTPS browser. Now, the reason why this happens is application detection. It requires certain amount of packets for the application to be correctly identified. Until if the firewall is not getting those sufficient number of packets, firewall might misidentify the application. So you instead of seeing application, you might see HTTPS browser, or maybe you're accessing certain application. Let's say instead of using Facebook app or instead of using Gmail or Outlook, you are using them from your browser. So if firewall tries to detect those signatures, firewall might see a lot of signatures pointing it towards the browser. Now, another way, the way a firewall work is, let's say, if I am trying to access certain application like Facebook or Instagram from the browser will add its own metadata in the header. Now, those metadata, if they are read by firewall might detect them that these applications are coming from a browser, and it will end up identifying or classifying them as HTTPS browser. So this is very common, but once the firewall gets a sufficient number of packets, the reclassification will happen. The firewall will again change them back to the correct application. Now, another example is for there's a game called World of Warcraft. Now, this World of Warcraft uses BitTorrent to distribute the patches to all the players. So now, if this game might get detected as P2P protocol or something else because P2P protocol is a well-known protocol which is used by a lot of application. So instead of detecting it as a game, maybe firewall will detect it as something else because the number of packets are not sufficient enough. So I just wanted to give this clarity. And there is another scenario where, for example, you can visit a website, and this website might have a like button that will redirect you to Facebook or maybe an Instagram post. So this traffic, the signature of this like button can be embedded in that website, and firewall might detect that particular signature and then classify it as a Facebook traffic or something like that. So that is also possible. So basically, the firewall is detecting maybe it can detect any website as Facebook because it saw those signatures in that particular traffic. That doesn't mean that firewall is working wrong or its firewall is not classifying a website properly. One just because an element of Facebook like button or a Facebook page is available in that particular website, firewall has classified that particular website as Facebook. Now, this I can give the same example in another context. Let's say you are visiting a website and that website has an embedded video that is being coming from YouTube. Now, you visit the website, you might expect the firewall to classify it as some other application. But because this YouTube video is embedded in that website, firewall scans the traffic and sees a YouTube pattern. So firewall will say, okay, this application has also signatures that is related to YouTube. So it's not about the actual website or actual application which we are using. It's all about what kind of application traffic we are having in that traffic. What kind of pattern we have in that signature. That is what we need to focus on. Now, another important aspect or a benefit of this application signature is, let's say I have all these Facebook-based signatures. I want to allow Facebook in my organization, but I don't want anyone to do a Facebook watch videos on Facebook. In those scenarios, I can simply block this application. I can allow the entire Facebook, but I can block the Facebook video play. So users will be able to access any Facebook post. Maybe they can access photos. They can like a photo. They can post photos, but they cannot play a video in Facebook. So the same can be done for YouTube. So you can disable YouTube HD streaming. You can block it so users cannot enable HD streaming. So this will be beneficial for to use save your bandwidth. Then embedded videos. So this is one signature. So if any YouTube video is embedded in a website, instead of blocking the entire YouTube application, we can use this to block the YouTube and only the embedded video part, not the entire YouTube. Then you can prevent them from uploading. You can prevent them from playing the video. Depends. So whichever action we choose, we can do that. But this is only the signature part. This is not the actual control. The actual application control will be done from the application control where you have the default profiles and you can also create your own profile. So when you create your own profile, you don't have to select again a proxy or flow based, but instead we will go with the category. So every application will have its own category. So basically this application control profile is categorized into three parts. One is the category, then the application and filter overrides, and then the protocol enforcement. So we will discuss them one by one now. So in terms of category, so you can either monitor all of them or you can allow all of them. You can have your action being set, block or quarantine. When you quarantine, you again get the same functionality where you can quarantine that particular PC for a certain time being. Now, if I set all the categories to block, I still have the option to individually allow them. So it's not that if I set all categories to block, everything will be blocked. So maybe some of the applications they are in the cloud IT. So how to see what application? We can simply click on this view signatures, and for whatever application that is in that category, they will be available here. So P2P, most of the enterprise, I have seen they will block P2P, but let's see what signatures we have in P2P. So we have torrent mostly. Okay, torrent is a good protocol, but it's being misused a lot. So we can also block social media or allow social media. Let's see the social media signatures. Oh, there are so many applications which I'm not aware of. Okay. Now, once we select a certain category, once we block them, if they are blocked, there will be a log being generated in our uh, security events. So we will get to know, and we can also keep the action to monitor. So this monitor is not a permanent action. So you should not configure a profile to be in monitor mode and then forget it. So monitor is something where the admin choose to put them in monitor action, and you have to review the logs periodically, and then you have to change the action back to either block or allow depending on your requirement. So next part is the protocol enforcement. So protocol enforcement basically, if we enable it, we are restricting the protocol to a certain port or service. So if we know that HTTP is running on port 80, now if you have a if you have any other application that is running on let's say port 8080, and if you want to, if again if it's HTTP, if you don't want this, then you can block it. I mean to say, we know that HTTP is going to run port number 80, but if for some reason, if you're receiving certain application traffic, maybe you have developed your own custom application, and you which is running on port 8080, but you just use the HTTP protocol. So if you want to block them in your network, then you can block it using this action, or you can monitor it depending on your requirement. But this protocol enforcement, if this option is enabled, it restricts application to run in the defined port number. If any application comes in a random port number or custom port numbers, this option will start blocking it. So if we are choose enabling this option, we need to be careful, especially in scenarios where you have a lot of custom application traffic coming in. We need to make sure that all your services are running in the defined port ranges. Now, then we have the so Nagaraj asked the question: monitor and allow. What is the difference? So allow action will not generate log in every scenario, but monitor will generate logs for you. And it also allows the action. Now let's take a scenario. Let's say I have blocked P2P, but I again wanted to allow one application in P2P. So let's see, P2P. So let's say I want to allow B2B, uh, sorry, BitTorrent, but I don't want to allow the entire category. So I can create an override here. So this particular application will be allowed, but the entire P2P category will be blocked. So if you have blocked a social media, entire social media, but you wanted to allow again only certain application, then you can choose that. So filters. So you can either go with the individual application name or you can go with the filters. So in filter, I can select, let's say social media. So this will include all the signatures that is coming from social media. So there's so there is no point in doing it in this way, like where we block the entire social media and then again select the signatures here. But what we can do is we can again go with excessive bandwidth or evasive or botnet. Let's say we wanted to allow social media. So social media is allowed, but you don't want any of these any application which with these behaviors, like anything with a botnet connection, evasive behavior, or tunneling protocols to be allowed. So in that case, you can kind of select this and set the action to monitor. So now you have all these signatures selected. So now you can monitor this traffic. So if you see here, there's something interesting. Uh, Even your Facebook like button or plugins or video play, they are also been categorized under this evasive or botnet. So we don't know for sure, but in these situations, we don't know whether these are going towards a botnet connection or these are going towards genuine Facebook. So for this, we can create the action as monitor and then we can review the logs periodically. Recently, I saw an article where hackers were using Instagram comment to as a command and control server. So I'm not sure. I don't know exactly how they do it, but I read this article where Instagram comment can also be used for a command and control as a command and control instruction for their malware. That's something interesting. If you get a chance, please uh, go through that article, read it, and maybe you will get some idea. So it's not that we cannot trust every application. Even Instagram command can also be used for command and control. That's how advanced the cybersecurity has become. Now, again, in terms of signature matching, we will go from top-down approach. First Firewall will check the application and filter overrides, and then second, it will check the categories. So if we have any override created for a specific application, they will be allowed, and then the category-based filter will kick in. So if any application is detected in non-default port, what action to take, whether to block or allow? So this option can be controlled. And if we have if you want to log the DNS traffic, then we can enable this. Now, why we have this allow and log DNS traffic? Because sometimes your DNS can be used to tunnel other application as well. So that can be used here. For example, Skype is a tunneling protocol. So certain malicious applications they will be detected as Skype, but the same Skype protocol will be used to carry some other application traffic. So any HTTP based application, or if you're enabling decryption and if you want a replacement message, only if this page is enabled, the users will get a pop-up saying that you are trying to access this application. If this is not enabled, the users will not get the a pop-up. Uh, we are close to the time limit, so I will use the remaining time to answer your questions. So if you have any questions, please drop them on the chat. And there were a lot of other topics planned, but unfortunately, time is not favoring us. 6 days is not enough to cover entire FortiGate. There are a lot of other interesting features. So in the 6 days, what we have basically covered is we have covered how to configure an interface, how to get the initial access, the basic routing, and then we covered the firewall policy part. Again, in firewall policy, only we have covered a small aspect. There are a lot of other aspects to cover, which we don't have the time. And I got a lot of requests from you guys to cover HA and then IPsec. Unfortunately, we don't have the time for that. But definitely that will be covered in another session.